Okay, my name is Pradipta Mishra. So I work as a data scientist, and my core work is basically around machine learning and artificial intelligence. So that's all about briefly about me. And in this webinar, we are going to talk about what is data science, who are really data scientists, and what are the job prospectus in data science scope and opportunities, etc. So the agenda is here. So we'll follow this process and we'll understand like what is data science. So to start with, it's a study of data, how to make sense of data. That is most important. So, like all other topics could be statistics, data mining, machine learning, neural networks, data visualization. These are all related topics around data science. Now, the core of it is data science. Why data science? Because it's a science of extracting insights, meaningful insights, or actionable insights from the data. Now, for example, there is, let's take a project where a lot of sensors are integrated and the sensors are generating data. It's getting stored in some databases, maybe some like it's a large scale data stored somewhere, but nobody has idea about what is this about, how they can make money out of it, or how they can make sense of the data. How do they use the data? So typically, data science is a science of extracting insights from huge amounts of data and how to make it usable for the business, how the business can make profit out of it, make money out of it, because they have spent a lot on building data science architecture. They have built enough data warehouses, right? Now, who is a data scientist? So, data scientist at the same time he's an analyst, he's a communicator, and an advisor. Now, when I say like a hacker, analyst, or communicator, or advisor, so it's really sometimes it's really confusing. But I'll tell you the pipeline or what should be the process a data scientist should follow. Now, given a business statement or given a business problem, the problem is, let's take I want to expand my business in XYZ country, or I want to have more customers. Now, whether it is a B2B business or B2C business, what are the key matrices to be tracked in a B2B scenario, in a B2C scenario? Can I have all the matrices in place? Now, that's you are acting as a domain expert. As a domain expert, you have to understand the key matrices and the factors that are impacting those key matrices. One example is like, let's take if I make my trip, so I would be interested in looking at more conversions. Whosoever is visiting my website, I would want many people to book tickets. That's my only metric. So the metric here is, I can say look to book ratio. Somebody is looking at a ticket, whether he's making a booking or not. So to increase the look to book ratio is my target. That is my business objective. Now for other businesses, they have their business specific key metrics that they would want to track. Given this scenario, a data scientist first has to understand the key metrics in business that's the domain expertise hat the person is wearing. Now, second step is basically to gather the requirement, then data collection, where the data is stored, how can I collect the data from different sources, and how do I process the data, where do I store the data, how do I make sense of it, right? So again, I'll go back to the first slide here, where domain expertise is required to understand the business matrices. Then stakeholder management. In the stakeholder management, typically you have to talk to people who holds data, who are the owners of the data, or who are the process owners. So if you need to change the process, you need to talk to your process stakeholders or management. Then the storytelling ability is also very important. Storytelling means what the data says, can you translate it into a business language or business statement? Similarly, business communication. Business communication is about explaining the stakeholders in their own language. You can't just say that, okay, this is the beta code, this is the alpha, this is the like chi-square statistics. You can't just throw the statistical terminologies to business people. You have to convert that to a general, plain, simple language, English language, to explain someone what it is and what does that mean, right? So these are the key the data scientist would always want to have. Now, given this background, so what we are going to do next is to understand how to become a data scientist. What are the key skill sets? The data science skill set sits at the core of three different fields: domain expertise, computer science, math, and statistics. When I say computer science, it requires well, maybe Python, maybe R, Scala, Java, anything. So almost all the languages, they have some degree of a machine learning library present at this moment. Some degree of data management tools or programs or packages or libraries are also present. So first get hands on those programming tools, maybe Python or whichever you are feeling comfortable or convenient. You just pick up that tool and then start writing programs. That is how you will build your expertise around computer science. The second domain is about math and statistics. Math and statistics, like basically linear algebra is very much important, because most of the mathematical calculations that are happening in real life projects, it involves some degree of mathematics. Okay, some degree of mathematics means like maybe eigenvalue decomposition, first order derivative, second order derivative, entropy calculations, etc. Little bit of linear algebra is very much essential in almost all the projects, because you'll be using advanced algorithms for that. Now, statistics is very important, because at the same time, you have to understand whether it is statistically significant or not. If you are saying, yes, it is statistically significant, how do you validate the hypothesis? Or how do you make conclusions from the data? To make conclusions from the data, you need to apply statistical technologies or statistical techniques. And at the same time, the computer science skill set also is required to handle huge amounts of data or huge volumes of data. Tools like you have a Hadoop, Spark, Hive, SQL, etc. Various tools, they perform various things, right? Now Hadoop is like good for storing huge volumes of data. Spark is good for processing that data. Hive is to write high-level query languages, right? Writing query languages to extract data based on some conditions, some loops, or some, maybe some hypotheses. SQL is about again storing the data and extraction of the data as and when it is required. So these three are very much essential tools. Like big data tools are very much essential. Now, at the same time, data visualization is also important. In large databases, when you have huge volumes of data, like maybe 10 GB or more than that, then we can't take it to the simple computer or single machine. It's very difficult to visualize, process, apply algorithms. It's really difficult. Now, in that sense, it is important to understand, or it is important rather to know what are the visualization techniques that can be applied or embedded to look at. Now, next thing is about statistics. So what level of statistics required? So I think in-depth statistics is not required. Maybe up to a graduation level statistics should be more than enough. Now, why statistical concepts? Statistical concepts provides you information about understanding relationship between various entities. How one common technique, which is very largely used across different projects, almost 80% of the projects are regression concept. Why regression? Because it helps you understanding the cause and effect relationship between various attributes. When I say cause and effect relationship, when I say cause and effect relationship, that means we need to understand what impacts what. If sales is impacted by number of people visiting the store, number of transactions happening online, or number of visitors visiting the website, how do we predict the sales? Can I do some kind of computation here, right? That's why it is really important to understand. It's really important to understand the cause and effect relationship.
Yeah.
And this cause and effect relationship can be answered using regression technique. Your target variable or your dependent variable would be the y variable, and you will have explanatory variables. And your explanatory variables will have associated weights. Those weights are nothing but your beta coefficients. To what extent each predictor is impacting the dependent variable. That's how the statistical concepts help you in understanding the relations between various variables.
पानी
When
जल्दी
it comes
निकाल.
to programming languages, programming languages are, there are two leading programming languages, R and Python.
हम
Python
दाल
is
जरा.
widely used for applications in, Python is quite flexible in terms of programming. You
जब
can
तुम
write
तब
programs like based on conditions, loops, etc., etc.
हो गया मेरा.
However, R is also good, and R is good for like people who are starting their career into programming, or people who are new to programming. They can start from R, and gradually they can move to Python-based programming. So Python and R, it is task based, and both are essential, both are required to be a data scientist. You need to know both the languages, because there are some instances where you would be doing a lot of statistical calculations or statistics related testing. Some of the tests are not available in Python. Some of the tests are available in R. Now, similarly, if you are working on NLP related projects or deep learning based projects, Python is pretty comfortable. And sometimes R is not suitable for that kind of work, or kind of like image processing, video processing, audio processing. It's quite easy for Python, because Python provides the stable APIs. However, R is not convenient for that task. Now it depends on task to task, project to project, and maybe I would say situation to situation, different situations. Sometimes you might use both the combinations of R and Python. Sometimes you will be using R only. Sometimes you will be using Python only. Now, thing is, depending on your core strength, if you are from a programming background, you can start Python first, then R. If you are from a non-programming background, you start with R first, then get into Python. So, understanding both Python and R is essential to be a data scientist. Given this background, Python and R programs, sometimes you will be like finding out like many links available online, R versus Python. Somebody is taking whether we should learn Python or we should learn R. No, I would say Python and R. It's not Python versus R. Why? Because both are essential. It's not like we can do everything relating to data science using only Python, or we can do everything using R in data science. It's a combination of both. That's why, given this background, next is big data technologies. Now, if I have, let's take a 500 MB file or maybe 1 GB file, I could process it in one machine. But if the size of the file increases, it is huge, like 10 GB, 20 GB, or maybe in some cases it is 100 GB. So how do I use it? So if 100 GB file I have received, I have to make sense of what is there in that data set. I need the help of big data technologies. So here I need Hadoop, I need Spark. I need Hadoop. Why? I need to put this file, this 100 GB data somewhere, so that I can run it in a distributed computing framework. Now, if I store the data somewhere in some databases, maybe local drive or maybe some other drives, if I store it, next step would be how do I process it? Processing can be of two types. Processing means a simple processing like running some queries and preparing some tables and the graphs and charts. That is okay. But if it involves some kind of a computational processing, for example, large scale, two different matrices, you want to do a multiplication. What is the best way to do matrix multiplication? Matrix multiplication is very computationally intensive task. Why? Large scale matrix multiplication requires huge memory to be processed. Now, what is the best way to do? Can we take the computation out and do something in the program? Or can we bring intelligent algorithms to process matrix multiplication in an intelligent way? That is one. The second option is, can I have huge, like large machines to produce the computations? There are two different ways. Now, if you look at applications like Amazon, or if you like look at applications like LinkedIn or Facebook, how they're doing large computations. For example, you have so many users. So the users are like 150 million users globally. Now, when you do some kind of computation involving 150 million users, and you are doing some kind of recommendation engines, either item to item like recommendation or user to user recommendation, you'll have 100 million cross 100 million records, which is pretty huge. Now, in this scenario, if you are doing a matrix multiplication, it is impossible, just impossible. Now, what is the best way to do matrix multiplication? How we can do that? Now, why matrix multiplication required? Because if you want to generate some recommendations, you need to run a collaborative filtering. Collaborative filtering is, again, it's a combination of your like what algo you are applying. If it is user to user or item to item, how you are computing it, right? So computationally intensive tasks, or computationally like if computationally more power is required, there are two ways to handle. Either you handle it using advanced algorithms like math, you use math to solve it, or you need big data tools to process it. So to process such kind of things, you need a distributed computing framework. So Distributed computing framework means you need Spark to process it. You need a cluster computing framework. In cluster computing framework, you distribute the data across different RDDs. RDDs are basically resilient distributed data files. When you upload a data, so multiple partitions of the data happens, and those different data chunks are stored in RDDs. Now you'll write RDD-based operations that has to be individually implemented on RDDs, and then you will collect the computed information and store combinedly and show it to the user. Now, in those situations, it is really difficult. If your data size increases, you need more processing power, better machines to process. So this is certainly a challenge in data science and in big data. So to handle those kind of scenarios, there are advanced tools definitely. Every day, some tools are coming up, right? Every day, some new processing methods are coming up. So in this space, the most leading softwares or most leading open source tools are Hadoop and Spark. Hadoop allows to store data and process large amounts of data when it comes to reporting requirement. So you have data in Hadoop. You can write some Hive queries to extract some tables and prepare some summarized graph or summarized chart or summarized tables. That could be like average sales by different agents, average sales by different SKUs, average sales by maybe different regions. This kind of reports you can prepare when your data is in Hadoop and all. But when it comes to implementing a MapReduce program, like performing a cluster analysis or cluster computation or implementing a k-means algorithm in Hadoop, you need to do that using a cluster framework like Spark, where you'll be writing advanced queries to extract data, and also you'll be implementing machine learning algorithms. The difference between Hadoop and Spark is Hadoop is helpful for storing huge volumes of data and processing the data to an extent. But when it comes to implementation of advanced algorithms, you need Spark for that. Hadoop cannot take care of implementation of advanced algorithms to process huge volumes of data. Now in Spark, Spark doesn't have its own storage. Spark uses Hadoop to store the data, and Spark runs on top of Hadoop to implement queries as well as to implement machine learning algorithms and graph-based computational things. So that's the difference between Hadoop and Spark, and ideally both are required in a big data space, or if your data size increases, you need. Now next comes data visualization tools. Why do we need a data visualization software or data visualization tool? Sometimes the numbers might not be correct. Sometimes the numbers may be similar, or sometimes the numbers may be very close, but they may be generated, or they may be getting generated from like different patterns or different ways it is being generated. For example, if I say average stock prices of so and so stock is 20 last month and this month, but when I say patterns, is it consistent? Is it consistent? May not be, because I have to see the consistency. If the average stock prices are same in 2 months, that doesn't mean that the consistency is similar in 2 months. So the consistency or the variation in the data as well as key matrices, if I want to look at simultaneously, I have to project it in a graph. So graphs help you, graphs typically provide information on the patterns, the associations, and the visual pattern is much more effective than the numerical numbers. If you represent the statistics in a tabular form versus you represent the statistics in a graphical form, the graphical form is more impressive. Graphical form is more meaningful so that the users can remember it for a longer period of time rather than looking at the numbers, because numbers nobody remembers. It's really difficult to remember a number. That's why many tools like Tableau, ClickView, they're leading this space by providing very good data visualization. Now, apart from this, there are some open source visualization libraries like D3JS based visualization libraries, and they are like open visualization tools are little bit configuration is required. At that time, like You can like import those libraries, but customization is required. So you need a little bit of programming to customize those graphs and charts. Otherwise, you won't be able to use it. And apart from that, the leading software tools like R and Python, so they have their own visualization libraries. For example, in R, you have ggplot2, you have plotly. Similarly, in Python, you will have matplotlib, seaborn, and bokeh. Matplotlib is the leading software in Python space to generate graphs and charts. So you can prepare graphs and charts while working on your data, and this is absolutely free. Similarly, if you are working on R, you can generate graphs and charts based on the libraries like ggplot2, plotly, Google visualization. So there are so many visualization libraries available in R also. Now, those tools, Tableau, ClickView, and Microsoft's Power BI, these are all enterprise-based tools, which involves some cost. Now, those tools are not free. So, and this is not open source. So, in data visualization space, as I said, there are like different ways. If you want a custom tool or you need support, you should go for enterprise-based thing. Now, if you are more towards like self-building programming or you are into like self-sustained data scientists, you would be probably looking for like D3JS based visualization because I mean, you can manage the programming and customization. So that's the ideal tool. Now, next big area is about machine learning. What is machine learning and why machine learning is required? Machine learning is basically, I would say there are three letters, P, T, and E. P is for performance, T is for task, and E is for experience. If the performance of any computer program improves over time relating to a particular task by learning new experiences, now that is a machine learning system. Now I'll expand all those three terminologies. So as I said, it's a computer program that learns from new data. So the terminologies are P, T, and E. E is basically your experience. Now experience comes from new data set, learnings, experiments, new observations, new instances. These are called your experiences. Task is relating to what you are trying to achieve. You are trying to predict something, you want to classify something, you want to group something, you want to recommend something, or you want to analyze something. What is the task that you want to do? And performance, how you are defining the success of your task. Let's take, my task is to predict, let's take Apple stock prices for tomorrow. If that is the task, now I predicted a number, let's take, I predicted tomorrow stock prices would be maybe $70. Now tomorrow, at the end of the day, I collect the actual value. Actual value is $75. My prediction is undermining the actual prediction. Actual is 75, my prediction is 70. So there is a difference of 5. Now that difference is basically the error which my prediction is generating. Now that error is basically a metric. So if your metric you are capturing, so your metric is basically your performance. If it is error, your objective would be to minimize the error so that your performance or the computer program's performance will improve. So the performance is defined as either accuracy or error. So accuracy is nothing but 1 minus error. So 100% minus what percentage of error you are getting. That's your accuracy. How accurate is your prediction process so that it can accurately predict what would be the stock prices for tomorrow. Now, given this background, so different tasks, they have different criteria to judge the performance of the computer program. The tasks, I'll expand a little bit here. The performance can be, as I said, accuracy. It can be root mean square error. It can be ROC. It can be area under the curve, AUC. It can be like classification accuracy. It can be MAP, mean absolute percentage error. It could be mean sum of square error. It could be mean square error. So there are different, or median absolute deviation. So there are different statistical terminologies associated with the error term. Now the error term is basically your performance. So if it is accuracy, the objective is to improve the accuracy. If it is the error, then objective is to reduce the error or minimize the error. Hence, the performance is defined in two ways, either improve accuracy or reduce the error. That's the performance of a computer system. Experience, I have already explained. New data set, new observations, new records, new experiments, or new learnings. That's your experience. So this experience, you are allowing the computer program to learn those experiences. Now looking at the term, the task. The task is basically, it is of four types: supervised, unsupervised, reinforcement, and semi-supervised. So when it comes to supervised, you have one output or target variable mapped to the input data set. For example, every time somebody is applying for a loan, he is getting a status. Either it is accepted or it is rejected. So there is one definite outcome from the loan application process. Hence, it is a supervised technique. Why? Because the supervised element here is the outcome of the application. When you are applying for a credit card, either it is getting accepted or it is getting rejected. So there is the definite outcome from that experiment. So when you collect all the applicants' status, you'll find some people would be approved of a credit card, or some people would be rejected. Now, that's why it's called supervised element. When I say unsupervised, there is no outcome from it. For example, if I'm a retail shop owner, maybe let's take I'm a Flipkart or maybe an e-commerce company, or maybe Amazon or Flipkart. I have no idea how many unique group of customers I have. What does that mean? Like what type of customers I have? Do I have more value concerned customers? Do I have more spenders, like they spend a lot? Or do I have misers who are reluctant to spend a lot on my website? If I want to know this kind of grouping, how do I group them? Because I have no tag like that. And when somebody is visiting my website in Amazon or Flipkart, it's not necessary that they will buy something. There is no definite outcome. They may not buy anything. In those cases, it is unsupervised. In unsupervised cases, you don't know what is happening. You don't know what is the prediction or classification. Simple thing here is to understand the associations, how things are aligned, how things are associated, right? So it is the unsupervised task. Now there comes the semi-supervised, where you want to understand few relations, you want to explore other relations through prediction process. When I say understand the relations through prediction process, so some records or some experiments or some input are tagged, some inputs are not tagged. Those inputs that are tagged, that would be supervised. Some inputs that are not tagged, that would be unsupervised. So in these cases, in the same training set, you'll be predicting the unlabeled tags and you'll include that in the training set. That becomes your semi-supervised. The last variant is about reinforcement learning. What is reinforcement learning? Reinforcement learning is basically, it's a state action reward punishment system. State is like, if I'm taking a session now, this is my current state. After 2 hours, what would be my state? Maybe after 2 hours, maybe I'm doing something else. So different state, different activities, different responses, and there is a reward and punishment system. One such example I would give, for example, maybe you have ordered for a coffee in a CCD or cafe coffee day. You have ordered for a coffee. Now, once it is getting delivered to your table, instantly you would like to have it and you touched it. It's very hot. So, I mean, by holding that, you recognize, okay, so this is too hot. Maybe I can allow some minutes to pass. You leave it there, wait for 2 minutes, then again you will touch. So eventually, at some point, you'll feel that this is appropriate. I can now hold it and I can have coffee. So the time it takes to adjust to the environment is called different state. Similarly, the reinforcement learning is applicable to chatbots, to the personal digital assistants, to various applications like robotic process automation, like AI. So almost all the AI component, wherever there is AI component, there is a feedback mechanism, there is a reward mechanism, there is a state, and each state will have a different reward or penalty associated with it. And the state to state, there would be transition functions. So from one state to other state, the transition functions will have different transition probabilities. So by taking into account the transition probabilities, you'll be predicting the probability of the next state or next stage where the agent will be in a particular environment. Now, when you say different state, now if it's the right state or not, if the person is in the right state, that action will get rewarded. If the person is in a wrong state, then a penalty would be given to the learning process, so that this kind of actions will be discouraged in the future. That's how this reinforcement learning works. Fine. So that's why the entire task space is sometimes defined, sometimes not so defined or not so clear. Given this background, domain expertise, how do you build domain expertise? So domain expertise requires extensive research. Domain expertise requires understanding of the business, understanding the processes, how the process works, how the businesses work. For example, let's take, I'm into a food delivery business. Let's take maybe Food Panda or maybe Swiggy or something. How does this process work? How do they make money? And what are their business proposition? So I need to understand what are the key matrices important for them and how do they make more profit. So to understand that, I have to understand the process. What do they do? For example, they receive orders through an app. They will search for the nearest restaurant that can be assigned to a person nearer to that place, and they'll ask the restaurant to prepare this, then get that food and get it delivered to the person. Now, in that process, there are various loopholes. If the person is at the restaurant's place and the customer cancels the order, what happens? If the person is not able to reach the destination, what happens? If the person is not finding the restaurant that the user is asking, what happens? So there are different scenarios. In different scenarios, what are the actions? What should the agent do there? The agent is the person who is supposed to get the order from the restaurant and get it delivered to the person. So to understand any business, you have to understand first how the process works and how, what is the key metric? How do they make money? Because whatever you are getting as a customer, they're also buying the same thing from the same restaurant. And if they're getting it delivered to your home at the same price, how are they making money? Right? So to understand the business, you need to know the process. Once you know the process, then you will understand what are the key matrices, what are the loopholes, or what are the faults in the current process, then how technology can improve it. That's how you will build the domain knowledge or the domain expertise. Now, when you know the existing matrices, you can think of how other matrices can be improved, how other matrices can be created, how new matrices can be created, right? So, given this background, how to build a domain expertise? Typical, I'll give you a process, a step-by-step process. How do you build your skill sets? How do you build your expertise in data science step by step? Now, looking at this process, understanding the business, understanding the data, understanding the business means the first step is to understand the process, how their business works. Similarly, supply chain or logistics, how the industry works, who are the key players. In supply chain, for example, the key players could be manufacturers, warehouse, distributors, retailers, agents, stock keepers, delivery agents. So then transport, how the transportation happens, how the route optimization happens, where the route is taking, and where the what is the ideal stock keeping unit of different warehouses. So there are so many things. To understand that, you need to first understand the business process, how the process works. Next step is set the goals. Once you understand the process, you know, okay, to improve the profit, let's take in supply chain, to improve the overall profit, I need to reduce the cycle time. So if from destination A to B, it was taking 20 days, now can I bring it to 15 days? Can I bring it to 17 days? If I can cut short that 2 3 days, that will improve the business profit by reducing the cost. So set goals. Now, goal setting can be executed at different breakpoints in a process, in a set process. Now, to set goals, you need to collect data. How do you know that on an average from destination A to destination B, it is taking 20 days? Now, 20 days is not for single consignment, it is average. So you need data to compute the averages, right? And again, it's a factor of road conditions, it's a factor of what happens, which day, what happens, is it a public holiday or it's not a public holiday? Was there any congestion on the route, or what happened? Is it a strike happened there in that route or not? There's so many factors to play. Now, you have to collect data to make inferences. There would be exceptional scenarios as well. So you need to collect data. Once you collect data, then it follows the normal data analysis process. You clean the data, you explore the data, what happened if some values are missing in that particular route. So can I impute it, or can I get it from some other sources? Can I get it from various places, right? Then can I model the data? Once you model the data, you'll find the reasons, you'll find some insights from the data, then you make decisions. And once you make decisions, you can say, okay, how my goals can be achieved. So what are the recommendations, what I get from this exercise? So hey, if I know that, okay, the top regions for delay could be like maybe lack of rest for the drivers. The drivers are sleeping overtime because they are fatigued to transport or to take products from one destination to other destination. Now, can I bring second driver also in each consignment so that the cycle time can be reduced? So that's one way. So if you know the reasons, you can make amendments, you can make changes, you redefine your findings. Again, you can collect data and see if it improves the established goals or established matrices. So these are typical steps in various data science projects. Similarly, the machine learning algorithms that I spoke of in a couple of slides back, the same thing is being explained here. Now here, we'll be looking at more algo side of it, relating to a particular task. The task, again, it can be classification, it can be regression, it can be clustering. Clustering is part of your unsupervised learning. Regression and classification, it is a part of supervised learning. When you are predicting something, what would be the sales, what would be the profit, what would be the rainfall here, right? If you are predicting the continuous value or a continuous output, that becomes a regression problem. If you want to classify something, like I have applied for a credit card, I want to know the status of it, whether it is accepted or rejected. I'll be looking at the classification algorithms for that. So classification algorithms help you to differentiate one group from rest of the observations, and there are various algorithms. You have support vector machine, you have discriminant analysis, you have a naive Bayes algorithm, you have k nearest neighbor, you have neural networks, and deep learning based models. There are so many techniques. Now, each technique will have different variants to it. The support vector machine can be used for regression, it can be used for classification as well. If it is classification, this becomes a support vector classification. If it is a regression, it becomes support vector regression. So those techniques are interdependent. Similarly, the decision tree can be used for classification, it can be used for regression. And ultimately, the decision tree is also a supervised learning technique. Similarly, ensemble methods. The ensemble methods can be used for classification purposes, and this can also be used for regression purposes, right? So the techniques, the tools, the optimization methods, the like assignment of values, splitting of a data set, then benchmarking the tools and technologies, right? So this can be done extensively using more examples, maybe by performing more experiments. That's part of your supervised learning. In unsupervised learning, you have k-means algorithm, you have k-median algorithm, you have fuzzy means algorithm, you have hierarchical models, hidden Markov models, again, neural network model. So neural network is something which can be used across all the tasks using like, so neural network is basically one of the most used machine learning technique which can be used in across different tasks. You can use neural network for regression, for classification, for clustering, for principal component analysis, for dimensionality reduction. Almost all the tasks can be done using the neural network technique. Now, these are algorithms. Given this background, tasks, yeah. So there are so many roles in data science: business analysts, data analysts, statisticians, data and analytics managers, and data scientists. There are so many profiles exist, and different profiles will have a different bent of requirement. What does that mean? That means we have seen the previous graph that there are different skill sets: business knowledge, math and stats, computer skills. Now, if somebody is very much into math and stats, little bit of programming and little bit of domain knowledge the person has, either that person can be fitted into a statistician's role or a data and analytics manager kind of role. If the person is relatively new to data science and he's good at like maybe programming, or he's good at maybe a little bit of math and stats and more towards programming, he can work as a data analyst. And if somebody is like good at domain and little bit of programming and little bit of math and stats, a business analyst. But if somebody is good at all four dimensions, domain expertise, math and stats, computer skill sets, then that's the ideal candidate for a data scientist kind of role. But if you look at in data science as a overall stream or overall profession, you'll find 5 different kinds of roles. Business analyst, it would be like more of like an entry level. Now, entry level, you have theoretical knowledge, you have not applied it to any practical projects. You'll be maybe working as an intern, or you'll be working as a business analyst. Now, getting exposed to various projects, you will learn a couple of things, then gradually you'll move the ladder to maybe a data analyst kind of profile. Now, once you move to data analyst, you are now pretty confident on the techniques, how it can be applied to data and all. You'll gradually eventually get more exposure to various techniques, how different techniques perform in different scenarios. Then gradually you'll move to statistician's role. Now, once you have good statistical exposure, then you can guide a couple of people, then you'll become a data analytics manager. Now, if you have managed a couple of projects, you know the approaches, you have closed various projects to a successful state, then you can become a data scientist. So this is just a journey. Now, somewhere you have to start. Now, if you have significant amount of experience and you have some degree of domain expertise, you have some degree of statistical knowledge over the years, and also you are very good at programming. I mean, you can start directly from data scientist job. So that's the job prospectus for data scientist. Now, here is a salary breakup of what the data scientist, data analyst, business analyst, statistician, and data analytics manager could earn potentially from various. I don't know the source of the survey. Maybe this is taken from some of the leading HR websites. Uh, but that's okay. So that's not the matter. It just gives you a ballpark number on like what could be the salary of a data scientist, or what could be the salary of statisticians, business analysts, and data analysts. Now, given this background here, the terminologies or the tasks that is present in data science. Big data, of course, big data is huge in size, volume, structured, unstructured, semi-structured, video, image, audio. These are all part of your big data. Now, if you have a huge video file, image file, how do you make analysis of it? Advanced data analytics, of course, yes. What kind of techniques and what kind of methodologies you'll be using to arrive at a conclusion. Data analysis, yes. Analyzing maybe relations, exploring associations, or making little bit of a predictions, etc. Data wrangling. Data wrangling is about combining various databases together, preparing a consolidated file, checking if there is duplicacy in various files, sanitizing the data, and preparing some kind of checks, hypothesis testing, and maybe basically framing hypothesis and testing hypothesis, etc. Descriptive is again, it's about understanding the like descriptive analytics is part of your exploratory analysis, where you'll be just doing univariate, bivariate, and multivariate of the data set. Univariate is about looking at each column in the database and understand their spread, associations, splits, and corresponding frequencies, etc. If it is like bivariate analysis, where you are looking at two variables and their relations. So two variables and the relations could be like categorical to categorical, continuous to continuous, or continuous to categorical. There are three kinds of variables that exist in a database, right? So that's part of your exploratory data analysis when looking at the binary or bivariate analysis. Then you have multivariate analysis. In multivariate analysis, again, you are looking at multidimensional scenario. If more than 5 variables, they are very close versus the other two in a data set, how they are associated, how they are correlated. At the end of it, deep analytics is about understanding the hidden patterns. Sometimes you overlook the association, saying that, hey, this is spurious correlation, this is meaningful, this is not meaningful. Why should I do that? But there are certain stages or areas where typically the things that you ignore, they are actually the truth. And that's what happening. Now, in that case, you have to go back to the business manager, asking them why it is happening and why it is happening or how it happened, right? Now, in the data science dictionary feature, so these are like various terminologies we typically use in data science pipeline. Feature is nothing but the columns. Any column in the data set can potentially become a feature, but all the columns can never be a feature, right? So all the columns in a database potentially can become a feature, but not all the columns are features. Please remember this thing. Why? Because in the customer's database, you might have a column name as a customer's name, customer's email ID, customer's mobile number, right? But these three things cannot act as a feature in your training data. But if I do some kind of pre-processing on that, they could potentially become a feature, right? So all columns are features, but all features are not columns. That's the logic. Similarly, looking at the predictive analytics. So in predictive analytics, you are creating features to predict the outcome variable or the target variable. Then you are making a model, and using that model, you are trying to predict. Using that model, you are trying to predict what is likely to happen on the test dataset as well. So given this background, the next step is about prescriptive analytics. What is prescriptive? So prescriptive is about once you predict this is likely to happen, now how can I avoid that? What should I do so that it shouldn't happen? Similarly, production code. Production code means you have a sample code that may not act in a production environment where multiple systems are associated. Multiple systems are associated or correlated. Different applications and APIs are present there. You have to change your code to a production level. To the production level, you have to change or convert your code to an API so that it can talk to various applications. Production requirements documents. So production requirement document means, is there any dependency? What are the dependent libraries? Different libraries that could be or that should be present, in fact, on the production machine or the server that you have to say. Similarly, statement of the work. So statement of the work means at granular level, you have to explain what is the deliverable, how you are going to deliver, what are the things you are going to deliver. Okay, we'll be delivering the production code, we'll be delivering, let's take the solution, we'll be doing integration, we'll be providing documentation. So many things you have to provide. And last but not the least, the target variable. Target variable is nothing but your dependent variable, your variable that you are looking at, or basically you are trying to predict or classify. The variable that you are trying to predict or classify basically is your target variable. Okay. Now that's all about various things, and at the end of it, so the data science again refers to the processes, the methods that help make sense of large volumes of data for achieving the business objectives. Now, business objectives has to be quantified, whether it is making more profit, whether it is reducing the losses. And these skill sets are high in demand as their skills are extensively required across various sectors. Now, looking at the demand and supply, the data scientists are huge in demand. So with this, I'm going to conclude the webinar.
Thanks, Pradipta, for your timing and all. So now I request all the participants have dropped a lot of questions in the chat box. So Mr. Pradipta will be taking these questions one by one. And also, like before that, we have also some few questions which we have collected, which you might have asked, which you might not have asked, right? So Pradipta, I think few questions are there, like which you can doubts basically, I will say, which you can share with the participants, which might be in their mind. So you can clear all those doubts right now, and also take the questions from the chat box, and if required, you can mute one or two guys and take their questions.
Yeah, sure. I'll do that.
Sure. Yeah.
One question comes like I'm from XYZ background, so can I become a data scientist? The answer is definitely yes. So definitely anyone can become a data scientist, given that right starting point. When I say right starting point, I'll just give you different paths. So I'll classify them into 4 different buckets: 0 to 3 years, 3 to 9 years, 9 to 16 years, 16 plus. People having 0 to 3 years of experience, they are relatively new to this industry. Now their core skill set can be either statistics or programming, because they would not have enough business exposure. So the ideal role for them would be either you become a very good coder, You can program, you are a very good Python programmer or you are a very good R programmer. That's your skill set, which somebody will be looking at if you are in a 0 to 3 years bucket. If you are in a 0 to 3 years bucket, you just master one tool, maybe R or Python. That's the starting point. Then you can move to other domains, or be good at statistics and be good at machine learning. Math and stats is the core field if you are in a 0 to 3 years bucket. If you are in the 3 to 9 years bucket, then you have some degree of business understanding. So you need to learn the business objective. You need to learn the business processes, how it works. And with that, you should have programming and stat skills. Now, a person with 12 to 16 years of experience, or 12 to 20 years of experience, I would say, or maybe 9 to 16 years of experience, they have enough, they have done significant work in their domain. They have good statistical knowledge, may or may not be. If they are from technical background, they will have solid technical background with domain expertise, not statistics. If they are from business background, they will have solid background in business and domain experts. They are domain experts. Now, if they're in 12 plus bracket, having no background into programming, they should more focus on business, like creating features, how feature can be enabled, how feature can be enhanced, what all new features can come, and how you can create products or services. That should be the more objective. And if someone in the 16 plus or 20 plus years of experience, then the person should be more focusing towards creating something new by maybe collating with various people across different skill sets. Can I create something new? Because having 20 plus years of experience, now if you have interest in learning new programming tools, learning statistics once again, and performing implementing some solutions, etc., that's great. That's great. So there is no strict guideline like you have to follow this route or that route. Now you start with your strong point. If I'm a programmer, I'll quickly master R and Python and Spark and Hadoop. If I'm an engineering background, I'm having engineering background and I'm very good programmer, I will quickly cover those things. Then I will enter into machine learning and statistics and understand what is happening. Okay. So understanding machine learning and statistics would be the secondary aspect if I'm from engineering background. Now, if I'm from a statistical background, I'll quickly learn my machine learning skill sets. I'll quickly brush up my machine learning math skill sets, mastery all the algos. Then I'll get into programming. Gradually, I will learn programming, because business will automatically come when you grow through the ladder of the experience. If you have already significant experiences, definitely you can learn little bit of math and little bit of programming also. That's one. What is the future of data science? That is another question typically I get. Future of data science is definitely bright, but the level is increasing every day. If you compare 5 years back, R and Python was people starting R and Python. Now, R and Python, last year, it was in a different state. Now, this year, it is leading towards artificial intelligence. Now, the bar is increasing every year. Every year, the expectation is increasing. Every year, whatever is normal now, or whatever is not normal now, that will become normal next year. So every year, the data scientist's profile and the level is increasing. So the sooner you master those things, you'll be in a comfortable position. Because every year, new things are coming up, and this space is getting little cluttered with so many tools, with so many algos, and because a lot of debate is also going on which algo is good, which algo is not good. There are 2,000 plus algorithms, or maybe in fact around 5,000 algorithms, I would say, totally that exist. And essentially different algorithms, they provide different output. How do you validate it? It's really difficult. So the space is getting little cluttered day by day. So the sooner you have solid background and solid understanding about the terminology, concepts, etc., you'll be in a better position to understand what is happening and what will happen in future. Okay. How can I practice data science, or where can I practice data science? So to do practice, like, you have to first have the basic skill sets like Python, statistics, then comes the business, and then comes like maybe the business side of it. Okay. And the next question, should I do the data analytics course for data science course? Of course, yes, because data analytics is a part of your data science. If you want to bring, build specific skill sets, analytics skill sets, data analytics is a must. Data science is basically the overall domain. Within that, you will find all those things like machine learning, Python, data analytics, data management, machine learning, deep learning, Spark, Hadoop, everything will be there. I have a sample data set, which is it's publicly available, and it is also available in most of the Python libraries. It's called MNIST dataset. So MNIST dataset is nothing but it's around 1,000 objects or images extracted and fine. So this is an example where it's relating to image classification. So image classification using TensorFlow. So TensorFlow is a tool provided by Google Research to perform deep learning related activities. Now this neural network takes the handwritten digits. So if you write 1, 2, 3 numerical numbers in digits form, you'll write it in digits form, right? And that digits photograph has been taken. So different people, they have different writing patterns. Somebody will write 7 as straight 7, and somebody will write with a bar, right? So different handwritten patterns. By understanding the images or handwriting images, how can you predict that which type of digit it is? So the different states that the image is, the objective here is, can we predict whether the person has written 0, 1, or 2? So each record here, I'll explain the data set as well. There are around 50,000 training digits in this data set. We feed basically 100 of them into the training loop at each iteration so that the system will have seen all the training digits once after all 500 iterations. Now that's called epoch. How many epochs you want to run? Okay. And typically, so I'll just first, I'll bring the data set here. So TensorFlow is again example. This is a TensorFlow example. So here I'll just run this, bring the data here. This is training image, all the training images. Now I'll be using matplotlib and numpy and random function. Here I'm designing the training size, test size. Training size, here I'm taking all the training images from this and printing the training size here. I'll come to this explaining what goes behind this training step here. Then here I'm just taking the images, all the images in training set and all the labels in the Y set. So the labels are basically 0 to 9, whether the digit is 0, 1, 2, 3, etc. Whatever is not there here in the training set, that should be part of your test set. So we'll build a model on the training set, we'll apply it on the test set, and then we'll make predictions and compute the accuracy, the predicted values or predicted classes for this. So next function is about display the digits. Here it has 784 pixels. Now 24, it's converted to a grayscale score. So by converting the objects into a grayscale level, it has 28 cross 28, which means 784 pixels for the data set. Now each sample will have 784 features. Now those 784 features can be used to predict what is likely to happen or how you can predict which digit it is. Fine. This is basically your display digit. Next step, next function is about using those 784 features. Can I do like a display, right? So display function is here. Randomly, you will pick up one object from the training set and see what is this object. Now here, the training set has training set has 55,000 records, 784 features. Your target variable Y variable has 55,000 records and 10 digits. So each record will be corresponding to one digit. It is 0 or it is 1 or it is 9. So any one digit. Now if I change this, randomly it picks up a digit and it extracts the exact shape of the object from the training set. Now this is the image it is picking up. Now if I randomly pick up, this time it is 3, 0, 1, 2 and 3. If it is 3, the example number is 38,230. That means this is the row number. The row number is 38,230. The label is 3. And this is the image written, handwritten 3. Somebody has written 3. It is converted to a grayscale. Now it has 28 cross 28 features, right? And 784 pixels are there in this image. Now this is one record, 38,230 record number. The target variable is 3. The output is 3. That's what we are trying to interpret from this. If you want to see the multiple features, now this is the multiple feature. Now here I'm just displaying 400, right? So which may not be making sense. Now this makes more sense. Why? Because if you repress it also, you will get another digit. Now this time it is 8. 16,855 is the record number and the label associated with it is 8. If it is 8, then it will be 1, else it will be 0. Fine. Now we'll build now TensorFlow session here to predict which digit it is. So import TensorFlow as TF, then build a session. Now you have to create a placeholder because you don't know the record space here. Record space none. Column space 784. So 784 features are there. So column space would be 784. Now row feature will be decided by the batch size. If batch size is 100, so this will be dynamically decided as 100. That's why it is left blank. Now this is the TensorFlow placeholder, means we are creating a training set of number of records we don't know. That will be decided by the batch size again, and features we know. So this is the placeholder. Similarly, I'll have the Y placeholder as well, where the outcome is 10. Now this is your Y for record number 16855, where 1 means this belongs to the level 8, else it is 0 for others. So each record will be corresponding to one level, and the level it is belonging to will have a value 1, else 0. So your Y is having 10 columns. So it's a matrix. So your Y will have 10 columns. Okay. Now to do this, you need to do a matrix multiplication here. How the matrix multiplication will work, right? I'll explain that. The matrix multiplication would be on the basis of, the matrix multiplication would be, this is your training set. Let's take 100 records. I will take 100 cross 784. Now you have a weight matrix. The weight metric would be again 784 cross 10. Fine. And your output would be, your output or Y would be 100 cross 10. Now this is your input, this is your weight, and this is your Y. So this multiplied by weight plus your bias equal to your y. Now that's what we are trying to do. X is basically your input. W is your weight vector or weight matrix, in fact, in this case, plus your bias. This is equal to y. That's how you will define your equation here to build a TensorFlow session. Now, after doing this, you'll move to the next step, right? Compute the weight and bias. So bias having all zeros, then weights 784 cross 10. Then you have this equation that regulates how the computation should happen. Then it uses a function called softmax. Why softmax? What is softmax? So softmax is a function, or essentially softmax is the algorithm that works best relating to a classification. So for a classification problem, the activation function that works well is softmax. While applying on a vector, it is done by taking the exponential of each element and then normalizing the vector. So basically it's using the ordinary Euclidean distance, that is the length of the vector. And how it happens? So you have the softmax function. Softmax is, here you will define softmax equal to L, which is equal to e to the power L divided by e to the power L times e to the power L with modular values. That this is your softmax function. And what is this L? This L is nothing but this equation is your L. That's how you'll proceed with softmax. Now, why the softmax is called softmax? The exponential is basically a steeply increasing function. It will increase the differences between the elements of the vector. It also quickly produces large values. You may normalize the vector, the largest element, which will dominate the norm. And this will be normalized to a value close to 1, while all other elements will end up divided by large value and normalized to something close to 0. So the resulting vector clearly shows which was its largest element, that is the max, but it retains the original relative order of its value. Hence, it is called soft. That's why it's called softmax. Softmax is again very much relevant in case of a classification problem. Now, having said that, let's look at how this performance works. So this is the training step. Now in the training step, total training images 55,000. And here, let's run the session. Then comes the cross entropy. What is cross entropy? Okay, so entropy means impurity. In information theory, entropy means impurity. If something is not clearly classified 0 or 1, then it's called impure, right? So max entropy. So the cross entropy is basically a function of weights, biases, pixels of the training image, and its known level. If we compute the partial derivatives of this cross entropy relatively to all the weights and all the biases, then we will get something called gradient. Now, this gradient is computed for a specific image, level, and present value of weights and their biases. So we have how many weights here? 784.
Hey, Pradipta, sorry to interrupt.
With 10,
I'm
so it would be
Satya.
7,840 weights and corresponding biases also. So computing the gradient, it will take some time. Hence, I'll just quickly move to the next step. Next step is about a training step. So here I have separated the training data and test data with a smaller set of information. Training levels 5,500, Y training 5,500, test a larger set 10,000 I have taken here, Let's run the model here. And let's see how the accuracy is changing and how the loss is reducing.
Hello.
Yeah, please go ahead.
Yeah. So I think we could take some few questions from the audiences. I think let them ping one by one in the chat, and then we can take the questions. And so I think that might help them.
Satyam, let's do one thing. I'll go through the questions that have already been said before.
Yeah, even that makes sense. Yeah, sure. Yeah.
So maybe that may answer some of other questions as well.
Absolutely. We can start taking the questions from the chat boxes. Yeah.
Yeah. So I'm just going through that. Question number 1. Why Spark is required in terms of machine learning? Because Python or R is there to do the job. Good question. Now, let's talk about comparing a logistic regression model on 50,000 records using Python or R and versus Spark. For large scale computation, you need Spark. Now, if you have 100 million customers data and you need to run a logistic regression, you can't do it in Python or R. You need PySpark environment. So Python plus Spark required, or R plus Spark required. So you need Spark along with Python or R to perform that task. Okay. Is it feasible to use both Hadoop and Spark concurrently to solve our purpose? Hadoop is a distributed storage platform. Spark is a distributed cluster computing framework. Spark doesn't have its own storage unit. Spark uses Hadoop to store the data. Hence, you can use Hadoop and Spark both. What is the current demand of Hadoop in software industry? Hadoop, it's still in demand because you need to manage large scale data. You need to store it, you need to retrieve it, you need to maintain the clusters, you need to maintain the machines. So it is required. How about Octave and MATLAB? Are they better compared to Python or programmers? MATLAB is not for good data sets, large data sets. Even Octave is not. The problem is Octave and MATLAB cannot talk to Spark or any distributed computing framework. However, Python and R, they have APIs that can be integrated with Spark. Couple of graph libraries available, which one to use here? Yeah, graph libraries, if it is R or Python, you can use Seaborn, Matplotlib, Bokeh, ggplot2, plotly. All the libraries support all the graphs. It depends on which one you like. The differences would be maybe syntactic differences, maybe color combinations, color scheme, maybe maybe little bit of functionality like hovering and seeing like dynamic charts, etc. You can assess which one you are comfortable with. For the beginner's point of view, what software should we start to learn data analytics? If you have prior programming experiences, you start with Python. If you don't have prior programming experiences, then start with R. How to identify features in image processes? Image processes, it will have standard grayscale images, grayscale features. So in this example, you have grayscale images of 28 cross 28, which is 784 pixels. So 784 features you'll have. Is there any other storage system available for Spark other than Hadoop for large volume of data? Maybe you could go for SQL, but SQL is slow. So you should go for Hadoop. Hadoop goes well with Spark. Yarn is one of them. Yeah, Yarn is a cluster management framework. Okay. So Yarn is not a tool. Yarn is like if you expand it, it's called yet another resource negotiator, which means it takes care of your cluster management framework. How much memory to be assigned, whether application master to be launched or not, whether the resource manager is consuming a lot of memory or not. So memory management, task management, job management, you need Yarn framework. Spark has its own Yarn. Hadoop has its own Yarn. So when you are using Hadoop, Spark with Hadoop, either you can manage, like you can allow Hadoop to do the Yarn and Spark for other computation. That is okay. That is one. The second way is let Spark use its own Yarn and use Hadoop only for storage. This is the second one. Any one of them, whichever you are comfortable or convenient, you can use it. Free sources to learn the code to, yeah, so you can go through scikit-learn website. Scikit-learn website should be good enough, but you need someone to guide you. You can start, like these are free sources, you can learn machine learning. Thing is, if you have a little bit background and little bit understanding about how machine learning works, then you can proceed further. But initially, if you're purely starting from scratch, it would be little confusing. You need someone to guide you. Spark working on top of Hadoop. So when using Spark, must be running on active Hadoop daemons. Correct? Yes. Spark using HDFS Hadoop file system to store the data. Processing will be done in memory through RDD. Oh, Mohammed, I think you are answering the question. Okay. Any tools to get accuracy? Accuracy is about like you can write. So in this example, if you see the accuracy here, what is the accuracy? If I want to see that, this is the accuracy. You can write a program to get the accuracy, how accurate a system is. You don't need external tools to get accuracy. How machine learning can be implemented in case of a quantum computing? Well, you have to define the problem there. In quantum computing, is a very vast field. You have to come to a task. If you have a larger task, break it into smaller tasks. Each smaller task, whether it fits into a regression problem, it fits into a classification problem, it fits into a clustering problem, you define the problem. Then once you define the problem, then select the candidate models. After identifying the candidate models, then look for the libraries in machine learning. Which machine learning library can be used to leverage this kind of a model in this kind of task? Then certainly you can use it, but you have to break it into at a smaller level. Do I have to learn Hadoop before learning Spark? Not necessary, because if you are from the engineering background and you want to be in the engineering side of data science, then there you don't have to work on the algorithms. So you can work with Hadoop. But if you want to work on the algorithmic side of it, like implementing machine learning algorithms or maybe statistical modeling side of it, you can connect Spark with maybe Python or R. You don't need Hadoop skill sets for that. Can we get links for downloading the beginner's software requirement? I think Satyam can answer this question. I have learned both. I found elementary knowledge of Hadoop is better to start Spark, learn Scala to write Spark programs. Yeah, thanks, Mohammed. What programming languages are used to write the Spark programs? You can use Scala, Python, then R, and Java. All four. Oh, you have answered this question. Okay. I am 42 years old and off from studies for many years. While I am from commerce background, I did have elementary calculus and statistics in my graduation and PG. Can a person of my profile manage data science curriculum successfully, or is it the domain of people from science and engineering background? No, definitely you can. Definitely you can. So if you have calculus and stats, definitely you can build your expertise around algorithmic side of it and gradually move into like little bit of programming should be okay, but more information, more knowledge on stats and calculus and algorithms is essential. Definitely you can. Okay. Can people from commerce background learn Python and R? Definitely yes. Why not? Do you need good programming skill sets for learning RPA? Yes, that is required. Maybe typically Python is required. It's a challenge for you to become data scientist because you should have good understanding of many CS terminals, but of course it's not impossible. Yeah, Mohammed, I think you are answering this question. Yeah, good. It doesn't require any prior programming knowledge. Yeah. I don't have knowledge on big data and Spark. Can I learn data science? Yes, certainly. You can. See, it's learning is a matter of time and dedication. If you are completely dedicated to a particular field, tool, and you have plans, definitely you can be successful in that area. What do you mean by wrangling analysis? Okay, so data wrangling is basically around, suppose you have 10 different databases. Few columns are consistently juggled up in those 10 databases, and few customers have duplicate entries in those databases. How do you prepare a consolidated file which is not duplicated, not having duplicate records, not having duplicate columns? Now that's how the headache comes, how to clean it up properly. That's part of your data wrangling exercise. Punit, I think answering this question. Okay. For getting into big data field, what are the essential things I have to learn? Yeah, I have told you. So like, again, start with your strong point. If you are from programming background, quickly master R, Spark, Hadoop, Python. And if you are from stats background, quickly master the algorithmic side of it, then learn programming. What kind of quality framework should be established in analytics process? See, quality framework could be maybe understanding the accuracy, stability, reliability of the modeling framework, and tracking the model performance over time, and raise a flag whether it is not whenever it is going wrong. Is there any direct relationship between big data analytics and business analytics? Not really, not really, because business analytics, I think, is the starting point in the hierarchy, and the big data analytics is basically it's at a very high level thing where you need a lot of other skill sets as well. What is the duration of data science? See, duration is, I mean, it takes time. So because to get mastery over one tool or one domain, it takes time. And now it's a function of how soon you can get mastery over one tool or one program. Can you explain with simple example how we implementing data science? Okay. You may be using Uber for booking cabs and all, right? So when you are outside of your home destination, and suppose you are from, let's take Delhi, and you travel to Mumbai and you are coming back from Mumbai. Then once your flight landed in Delhi and you are trying to book a cab, the first destination it will show your home, right? It will not show any other destination. And that's because your algo understands last 24 hours you were out of your home location. Now system understands what is your home location, what is your non-home location. Now, if you are with a gap of certain duration, you are landing in your home location, the most likely chance is that you will be trying to book a cab to your home. Hence, your recommended destination would be first your home. Now, this is just one example of how data science is being implemented. Similarly, Google Maps. How the Google Map corrects the destination time given the traffic and corresponding movement of others. Simultaneously, if 10 people are traveling in a route, 10 people would be at different points on the same route. Some people would be approaching the destination, some people would be 80% of the destination, some people would be 50%, some people would be 10%, some people would be starting from the destination. So if you take destination A1 to destination 2 or destination A to destination B, in the same route, multiple cabs will be plying, and different cabs will have a different response time. And if they reach the geographic location, it will send a signal saying that where the cab is. Now, taking this information, how Google Map corrects itself and shows you accurate result, where is traffic, where is no traffic. That's another example of implementation of data science. Can an electrical engineer be data scientist? Of course, yes. There is no issue at all. Mohammed, I have 12 years of teaching experience at engineering colleges. I have learned Hadoop and Spark and rapid miners, still not getting break from industry. What should I go for to get a break? I felt it's negative impact. Can you suggest what to do? Sure. So I would suggest you maybe the good thing I can probably recommend you is there are a lot of conferences happening. There are so many conferences around data science, analytics, and big data. Now you pick up a problem that industry is struggling. Suppose let's take finance industry. So whichever industry you are comfortable, pick up one industry and pick up a use case and show your expertise in how Hadoop and Spark can solve that problem. Use those technologies that you have learned, deploy a prototype, write a paper out of it, and apply those conferences where you can project it or you can show your expertise. Now, definitely the conferences will accept it. Now, when the conferences accept, you will get like attention from other industry people who are struggling with that problem. So that's the first way to get a break in the industry. If industry can see your expertise, they can definitely approach you. And to show your expertise, you have to build something unique, challenging, new, and you should be able to project it to people in various conferences. If someone have experience in other technology instead of data science related, how to convey show experience of 3 to 5 years in data science career? That's a little tricky. That's a little difficult. So you should be like frankly saying that, okay, I have 3 to 5 years of experience in some other domain. I don't have experience in data science career. But given the other background, see, no experience is I mean, almost all the experiences are useful for future. Whatsoever domain, whichever work it may be, that will have different, definitely that will have result in future. You can use those skill sets somewhere in the industry. So not necessary to show it as a data science career. You can create projects. You can work on practical demos. You build your own GitHub repository and show your credentials. Your credentials will talk for you. Okay. I have 2 years of experience as a database developer, and how I now I have started learning Python. Great. When I begin learning something, I needed data to implement to work out. Yeah, so you should refer to UCI machine learning repository or Kaggle. Mohammed, I have BCA, MCA, and PhD in data science. Is at least stage. I have 12 years of teaching experience in engineering colleges. Yeah, I think Mohammed, I have answered your question. Yeah, so regarding data sets, please refer to UCI machine learning repository or please refer to Kaggle. I have 3 years of experience in Tableau, Power BI, ETL. Yeah, Tableau is one aspect of data science. You can integrate Python and R algorithms inside Tableau as well. That is definitely going to help you. Is there any future for Java in this field? Certainly, yes. Almost all the applications are in Java. Now, Java and Python integration is very important. Now you need Django. You need to learn Django. You need to learn Python so that you can integrate the algorithms in a Java platform. Create our own brand marketing strategy and then charge hefty fees for consulting. That's what I would have done. Okay. Best deep learning algo in R, Keras is the library, and deep learning algo is one that is only, see, deep learning is about DNN, CNN, RNN. RNN a recurrent neural network, DNN deep neural network, and CNN convolutional neural network. I'm working as a business analyst in life insurance domain. I'm very good programming with a Java background. Yeah, definitely you can move to data science as well. Where is the usage of Pig and Hive? So Hive is, again, if you are only working on Hadoop and you don't want to work on Python and the R side of it, right? So definitely you can use Pig. Pig is for like analyzing the data within Hadoop environment. Okay. Pius, your question, it has everything. How does that compare? How about SAS? SAS is a little slow in this race because the open source softwares, once it is developed, then SAS is building equivalent of it. But nowadays, one thing to remember, SAS has disabled the support. The algorithms you can use at your own risk. They will not support it. That's one challenge with SAS. In that sense, SAS is not different from, again, Python or R. Does data analytics applicable in the field of IoT? Yeah, very much. IoT is the field where data analytics and data science can be applied. Spark ONAR means saying standalone? Yes, correct. Is cloud and data science interrelated? Of course, yes. The algo you will be implementing, that would finally get deployed on cloud itself because your applications are hosted from cloud itself.
Yes, this is Nilotpal here from Bangalore.
Yes, please. Yeah.
Yeah, actually, I have 16 batch pass out, fresher, and I'm working as a database administrator in Bangalore from last
Yes,
6
hi. You have a question?
So I want to go ahead with data science field. So how should I start this? Because I don't have any much broad experience in data science and machine learning, Python, or I'm totally new to this field. I'm working as a database administrator and I know SQL and all. I'm working on IBM database like Informix, Oracle, DB2. These things I know.
Okay. So in this case, I would say that start first with the programmings like R or Python. That is first step. Now
Okay.
you have to get into it.
Okay.
Spend at least 30 days on R and Python and whatever you can quickly learn. After 30 days,
Okay.
then next 30 days you spend on machine learning. Okay.
Okay.
Now, after 60 days, you start appearing for Kaggle competitions. In Kaggle, you
Okay.
will get data sets. At least not if not participating in the competition, you are not able to meet the timelines, deadlines in competitions. That's okay. Just download the data set and do experiments. Compare and validate your output with the leaderboard's output. In the leaderboard, you will find a
Okay.
couple of people holding the accuracy at some level. Now, though you are not participating in the competition, but you do it offline and you match your accuracy with others, you'll get a you'll get a like feel of like where you are standing in the competition, right?
Oh,
Now that will give you a lot of boosts and confidence in getting into the data science field. Now, first that you build demos and build a GitHub repository of experimentation. Do many experiments and every day read at least 5 to 7 articles on data science and new technologies and terminologies.
okay. So from where I can get these terminologies and articles about
It's
data science,
free.
and from where
It's
I
free.
can get that data sets?
You can visit MIT or Harvard website. You'll get plenty of things free.
Okay, MIT and Harvard
Yeah.
website, right?
Yeah.
Okay, and from job perspective, how can I build my resume? Because I have 6 7 month experience as a fresher. I started my career last year in my June.
Mhm.
So after getting how much experience I should move after learning all data science and machine
Experience
learning, like R,
nowadays.
Python.
Well, nowadays experience is not about years of or months of experience.
Okay,
Nowadays experience is about how many unique solutions, scenarios, or learnings you have. So,
o-
if in 30 days, if you have done 10 projects and this is 10 learnings for you, and you can explain to someone, hey, I have learned 10 new things on those 30 days. Now, those learnings will help you get a job. It's not about like the length, like how many years you have experience. That's why many freshers, they're cracking interviews because they have done something which is significantly different from what the others are doing.
okay. So it's totally depend on my skill set, what practical
Exactly.
knowledge I have
Exactly.
about data science and all.
Exactly.
Doesn't require much more experience and all I have to
Yeah.
show, right?
For that, you need to do more experiments.
Okay, more practical knowledge about this.
Yeah. Yeah.
Okay, thank you so much.
Yeah. Well, and yes, I'm from data warehousing background, having solid knowledge in Hadoop and ecosystem like Pig and Hive Scoop. Started learning Apache Spark. Should I learn Python or Scala for programming in Apache Spark? Certainly, yes. Because you need to implement PySpark, you need to learn Python as well. So if you want to implement machine learning algorithms in a Spark environment, you need Python Spark, PySpark. Scala that certainly you can pick up, but PySpark would be a better consistent application. Sanjeev, I have 20 years of experience. My experience is in Java. Now currently in management role. So what would be the best way to start, and does I need to quit into programming to start with? Not necessary, Sanjeev. So you have 20 years of experience. Now what you can do, you should be able to know that what are the steps in the data science process and how to build a team, how to clearly separate the tasks, maybe data management, Spark, Hadoop, data analysis, statistics, mathematics, algorithms. Can I separate teams, and how can I get all the teams work together to deliver something new? That should be. I mean, you should be knowing the processes, the steps, and you should be knowing what tool, what it can do, how algo can be implemented. You should not be knowing the nuances of the programming, but you should be knowing how it is getting done. The how-to part of it, you should be able to know. For that, I think you need to know the data science processes and all. Then you can design your own architecture and a plan to implement projects.
Hello?
Yeah.
Hello, this is Balan, sir. Hello?
Yeah, hi.
Hi, this is Balan from Chennai.
Yeah.
Regarding my question for learning Apache Spark, right? Should I learn Python or Scala?
Python.
Yeah. So we also have the Scala, right?
If you want to
Sorry?
learn Scala, I would not say no, don't learn it. Now, it depends on a use case. But if you are feeling more comfortable in Scala, go ahead with that. But PySpark has more options. Scala is more optimized. Scala is more optimized. PySpark has more options.
Okay. So yeah, both are new to me. I'm having an idea in shell scripting as well. So I can learn Python or Scala. So it's better to go with the Python, right?
That's what I'm saying. So options means you want to implement the rarest of the rare models or complex models. PySpark is best.
Okay.
Now, if you want most performance-wise, most optimized solution, you should go for Scala.
Okay.
If a function is not available in Scala, it is available in Python, then you should not become okay, I mean, how do I do it? Right? You should be able to use it.
Okay. Got it. Yeah. Thank you, sir. Thank you.
Bharat, thanks for the session. Yeah, thank you. I'm working as a data analyst using Python and has 3 years of experience, but I don't have confidence on machine learning. Yeah, please do practice. Machine learning is about learning and do practice. More experimentation required. What do you mean by learn machine learning? You mean algorithms? Yeah. So machine learning is about like how to write programs to automatically pick up the parameters, find the accuracy, and correct the measures. That means correct the parameters to get best accuracy. Auto refinement of hyperparameters. That's what I mean. And does any data analyst works in the field of defense? My main concern is over security parameters. Yeah. So no, internally they should have some protocol. May I know your technical background? Yeah. So over last 7 years, I'm working in Python, R, Spark, and machine learning. That's my technical background.
Yeah, hi, I'm Nishin. Sorry for interrupting, actually. Yeah, I'm from Bangalore. So currently, I'm working as a data processing in level Spark, especially with Scala. So I'm planning to learn data science. Can you please suggest me what kind of our data science curriculum will bring us to learn at end of our session, end of our course? I'm sorry.
Mostly, you will be focusing on machine learning, deep learning, and how machine learning and deep learning algorithms can be used in a big data space using Spark. And to implement machine learning, deep learning, you need to know programming language like R or Python. And for that, you need to know a little bit of statistics.
Yeah, I have across our session, but I came across statistics and the remaining things. Is it really required to learn to be a data scientist actually?
Gradually, yes. I mean, at one day, it will not happen. It will take time, but it will become.
Yeah, thanks for your answer.
Yeah, thanks everyone.
Yeah, sir, what about the job market about data science? I want to know about the job from job perspective about data science. What are the opportunities? What kinds of companies hiring data science graduate and all?
See, regarding job prospect, I would say for skillful people, there is plenty of jobs. So it's not like it's not like just getting a certification or getting a certified thing will get you a job. My suggestion would be build your expertise. Build your expertise, put more efforts, and be good at least one thing. Maybe let's take a simple Python thing or simple Spark thing. Build your expertise around something. Now, if you have an expertise in something, definitely there is a job, and there will be plenty of jobs also. But you need to build your own core expertise. That is most important.
Okay. Okay, all right. So, how can I get project into that? How can I make project in Python and all? From where I can get help regarding this?
See, to start things, do a research on finding a business problem, understand how it is getting solved nowadays, think about one innovative solution, how it should be ideally solved, build a prototype, and attend conferences, show it there, then you will definitely find a buyer for that. That gives validation of your ideas, your implementations, and like your skill set as well.
Okay, thank you, sir.
Yeah, so like anyone have any doubt, they can like ping their, they can call us at 08045453161, and or else you can write us on inquiry@acadgild.com.
Acadgild. Average is dead.